Hello, Math 2 students. Today, I hope you're ready to learn about similarity. All right, make sure you have your notes and a pencil out, and let's do these examples together. This diagram shows a transformation that's called a dilation. In a dilation, we have a center of dilation, we have a pre-image, and we have an image. When a polygon undergoes a dilation, what is created is a pair of similar polygons. So now it's time to define similarity. Polygons that are similar have the same shape, but not necessarily the same size. To be more specific, similar polygons have corresponding angles that are congruent and corresponding sides that are in proportion. Corresponding angles being congruent. If you look at this diagram, you can see that angle A and angle A prime are the same. They're both 112 degrees. If you look at the diagram, you can see that angle B and angle B prime are congruent. They're both 38 degrees. And if you look at angle C and angle C prime, they're both congruent. They're both 30 degrees. So in similar polygons, the corresponding angles are always congruent. What does it mean that the corresponding sides are in proportion? In our textbook, when they write a ratio of the corresponding sides, they always put the image on the top of the fraction as the numerator and the pre-image on the bottom of the fraction as the denominator. And so if you look at the diagram, B prime C prime from the image is over BC from the pre-image. Since B prime C prime is 20 and BC is 5, when we reduce that fraction, it's 4 over 1, or we could just write it as 4. And the same thing happens with A prime C prime and AC, and that becomes 16 over 4, which is also 4. And then A prime B prime over AB is 8 over 2, which also reduces to 4. So we can say that the sides are in proportion because when we make a fraction out of the sides, every pair of corresponding sides has an equivalent fraction. All of these fractions are equivalent to 4. In example 1, the problem comes with 3 parts. The first part is the similarity statement. Notice that this symbol replaces the word similarity. So if I read this statement out loud, the similarity statement says triangle TRI is similar to triangle XYZ. The second part of the problem is the diagram where they show us both similar triangles. And the third part of the problem is 3 possible proportionality statements. When we are looking at proportionality statement A, B, and C, our job on this problem is to pick the one that is written incorrectly. We also want to find out what the scale factor is for these 2 similar triangles. When I look at proportionality statement A, I need to be sure that we're writing fractions that have the image on top and the pre-image on the bottom. So side XY is 15 and comes from the image. Side TR is 6 and comes from the pre-image. Side YZ comes from the image, and side RI comes from the pre-image. And finally, side XZ comes from the image, and side TI comes from the pre-image. And because these are similar triangles, all of those fractions, which will be improper fractions with the large number on the top and the small number on the bottom, all of those fractions will be equivalent. In choice B, we have XY over TR, again, the image over the pre-image. And then we have RI over YZ. That's the pre-image over the image. That would be 7 over 17.5. That would be a proper fraction, But this is an enlargement problem, and so the scale factor will always be a number greater than 1. So choice B is written incorrectly. Choice C, if we look 15 from the image, 6 from the pre-image, 17.5 from the image, 7 from the pre-image, and 30 from the image, 12 from the pre-image. So all of those corresponding sides are made into fractions, and that is correct in answer choice C because it's the image over the pre-image. Now to find the scale factor, we can use any of those three fractions because they are all equivalent fractions. They're equivalent fractions because these are similar triangles. So if I write the scale factor as a decimal, 15 divided by 6 is 2.5. 17.5 divided by 7 is 2.5. And 30 divided by 12 is 2.5. So on this question, the scale factor is 2.5. In example 2, the polygons are similar and they want us to find the value of x. So they want us to find the missing side of the smaller triangle. In this problem, I'm going to assume that the larger triangle is the pre-image and that this is a reduction and the image is the smaller triangle. One thing that makes this problem difficult is the image is facing one direction and the pre-image is facing the other direction. So it's difficult to find out which sides are corresponding sides. So my advice for most students is to redraw one of the triangles so that it's easy to tell which sides are corresponding. So I'm going to redraw the image so that it is facing the same way as the pre-image and I can find the corresponding sides more easily. Now that I've redrawn the picture, I look at the black original image and I see that between the angle that has 1 mark and the angle that has 3 marks, there's an X. So I put an X between the angle that has 1 mark and the angle that has 3 marks. Between the angle that has 2 marks and the angle that has 1 mark, there's an 8. So on my red picture, between the angle that has 1 mark and the angle that has 2 marks, I'm going to put an 8. And between the angle that has 3 marks and the angle that has 2 marks, there's a 12. So on my picture, I will put a 12 between the angle with 3 marks and the angle with 2 marks. Now it is easy to see that the 25 from the pre-image corresponds to the X from the image, and the 30 from the pre-image corresponds to the 12 from the image, and the 20 from the pre-image corresponds to the 8 from the image. Now I'm going to write 3 fractions, and the fractions are going to have numerators and denominators from the corresponding sides. And I'm going to take the red image and put it on the top of the fraction, and the numbers from the black pre-image and put them on the bottom of the fractions. So my corresponding sides, x corresponds to 25, 12 corresponds to 30, and 8 corresponds to 20. Because we already know that these triangles are similar, we know that all of these fractions are going to be equivalent. So what I need now is I'm going to find the scale factor, and I find the scale factor by reducing the fractions. Well, I can't reduce x over 25 because I don't know the value of x, but I can reduce 12 over 30. 6 goes into 12 twice, and 6 goes into 30 5 times. I can also reduce 8 over 20. 4 goes into 8 twice, and 4 goes into 20 5 times. So I know that on this problem, the scale factor is 2/5. And I know that the fraction x over 25 has to be equal to the scale factor, or the fraction 2/5. So by using this equation right here, this proportion, I'm going to be able to find the missing side. So when I cross multiply, I have 5 times x will be 5x, and 2 times 25 will be 50. Now I divide both sides by 5, and 5 divided by 5 is 1x, and 50 divided by 5 is 10. So I just found out that the value of x, the length of the missing side of the triangle, that's the image, is 10. Example 3 starts out with the similarity statement that says triangle ABC is similar to triangle A prime, B prime, C prime. What that means is that triangle ABC is the pre-image and triangle A prime, B prime, C prime is the image. What they're asking us to find is the perimeter of triangle A prime, B prime, C prime, which normally would be easy. A triangle has 3 line segments. If we know the length of all 3 line segments and add them together, we will know the perimeter. But in this problem, we're only given one side of triangle A prime, B prime, C prime, and that side A prime, B prime, that's 3. So what we're going to have to do is use one of the characteristics of similar polygons to find the perimeter. Let's start with the ratio of the corresponding sides. So the ratio of the corresponding sides is the image over the pre-image, or 3 over 2. Now we're going to write down the scale factor. If the ratio of the corresponding sides is 3 over 2, when we reduce that, we will know the scale factor. Well, there's no greatest common factor for 3 and 2, so that is already reduced. So the scale factor is 3 over 2. Now, when it comes to similar polygons, the ratio of the perimeters is the same as the ratio of the corresponding sides and the scale factor. So now that we know that fact, we can find the perimeter of the image by using the perimeter of the pre-image. So this is the proportion that will help us solve the problem. We take from the image 3 and from the pre-image 2 equals the perimeter from the image, x, over the perimeter from the pre-image, 13.5. And when we solve that proportion, we will know the perimeter of the image. So when we cross multiply, we'll have 2x equals 40.5. And then we divide both sides of our equation by 2. And x, which is the perimeter of our image, is 40.5 divided by 2, or 20.25. Now we're going to make sure that this worked by actually writing the ratio of the perimeters. And we're going to change everything to decimals. So for the ratio of the corresponding sides, 3 divided by 2 is 1.5. For the scale factor, 3 divided by 2 is 1.5. Supposedly the ratio of the perimeters is 1.5. And now the final test, if we divide 20.25 by 13.5, the answer is 1.5. So the scale factor and the ratio of the perimeters are always the same in similar polygons. Example 4 starts out by telling us that the two pentagons are similar. The pentagon on the left is smaller, and we'll call that the pre-image, and they want us to find the area of that pentagon. Just using that pentagon alone, we don't have enough information to find the area because we only know that one side is 14 meters long. We also have an image that has a side that's 18 meters and a side that's 20 meters, and we know the area of that image is 850 meters squared. So we can't find the area directly, but we can use some of the characteristics of similarity to help us find the area of the pre-image. We will start by writing down the ratio of the corresponding sides. So in the image, the 18 corresponds to the known side in the pre-image, which is 14. So the ratio of the corresponding sides is 18 over 14. Now we'll write down the scale factor. To find the scale factor, we just take the ratio of two corresponding sides and we reduce it. So 18 divided by 2 is 9, and 14 divided by 2 is 7. So our scale factor is 9 over 7. Now we're going to write down the ratio of the areas. So one of the characteristics of similar polygons is that if you start with the scale factor and you square it, so 9 times 9 is 81, and 7 times 7 is 49, that will give you the ratio of the areas. So now we'll be able to write a proportion and find the area of our pre-image. We start with the image, which is where the 81 comes from, and then the pre-image, which is where the 49 comes from. And then we take the area of the image, which is 850, over the area of the pre-image, which is x. So by solving this proportion, we will be able to find the area of the pre-image. So we need to do 49. When we multiply 81 times x, we get 81x. And when we multiply 49 times 850, we get 41,650. Now we need to divide both sides by 81. And 81 divided by 81 gives us 1x. And 41,650 divided by 81 gives us 514.198. And that is the area of our pre-image. Now, to check and make sure this all worked, we're actually going to write the ratio of the areas. And we'll change everything to decimals. 18 divided by 14 is approximately 1.286. When I go to the scale factor, 9 divided by 7 is approximately 1.286. And when I take the ratio of the areas, it's approximately 1.653. And finally, when I divide the actual areas, 850 divided by 514.198, it is approximately 1.653. So what we just found out is if you start with the scale factor, that will not give you the ratio of the areas. But if you take the scale factor and you square it, then you will have a number that is the exact same ratio as the ratios of the areas of similar polygons. All right, Math 2 students, after watching this video, you should be able to use the characteristics of similar polygons to find missing sides, to find unknown perimeters, and to find unknown areas. Thanks for watching.